Hey there. Today we're going to take a look at an activity called ice cubes in a bag, and here's how it works. You are having an argument with your friend about what happens to the mass when matter changes from one form to another. To prove your idea, you put 3 ice cubes in a sealed bag and record the mass of the ice in the bag. You let the ice cubes melt completely. 10 minutes later, you record the mass of the water in the bag. Which of the following best describes the result? Circle your prediction. A, the mass of the water in the bag will be less than the mass of the ice in the bag. B, the mass of the water in the bag will be more than the mass of the ice in the bag. Or C, the mass of the water in the bag will be the same as the mass of the ice cubes in the bag. Now, if you can, we want you to describe your thinking, provide an explanation for your answer. Okay? Now, you might be asking yourself, well, what is mass? Good question. Mass is a measure of the amount of matter in an object or substance. The mass of small objects, like ice cubes, may be measured in grams, and that's what we're going to do today. We're going to measure the mass of these ice cubes in grams. So, now is a good time for your teacher to pause the video and give you a chance to make your prediction of what will happen. Will the mass change? Will it be greater than it was before? Will it be less than it was before? Or will it stay the same? So, what do you think? Here's how we do this little activity. So, the investigation went like this because I've already set this up and done this investigation. And I started with ice cubes, obviously, a Ziploc bag. I used a bowl because I didn't know if my Ziploc bag might have a hole in it. I didn't want water leaking all over the place. And I used a digital kitchen scale because this scale can measure in grams and it's highly accurate. So here's what I did. I put the ice cubes into the bag. I put the bag into the bowl. Now, the bowl and the bag will not affect this activity in any way because they will not change at all. Their mass will remain constant throughout. The only thing that's going to undergo any sort of change are the ice cubes. Okay. So I put the ice cubes into the bag into the bowl, and then I placed the bowl on top of the kitchen scale and I took a measurement. Now, you may not be able to read the numbers really clear, so I zoomed in just so you can see that little decimal point between that second 2 and 1. So a total mass of the bowl, the bag, and the ice cubes all together, 212 and 1/10 grams. Okay, 212 and 1/10 grams. All right. And it is in grams, even though there was a glare on the screen. You can't quite see my little G that's next to that last one. Okay, so here's what we did. I let the ice cubes melt for 30 minutes and I came back to check. And the ice cubes were still there, but they definitely had begun to melt. They definitely had started melting, but you'll notice that the mass has not changed, at least not yet. So no change to the mass. All right. So what do you think? The ice cubes haven't completely melted. Is your prediction changing? You may want to pause the video here, teachers, and have a little discussion. So anybody going to change their mind and go with a different prediction now? So after all the ice has melted, what's the result now? Well, all of the ice has melted from the bag. And you see I've hidden the number on the scale. So what do you think? Do you think there's been a change at all? Well, here's the big reveal. No change to the mass. The number is exactly the same as we started with, 212 and 1/10 grams. So Was your prediction correct? Now, here's another discussion question for you. Why do you think there was no change? Why do you think there was no change? This is a really simple activity. I think anybody could do it at home, provided you have all of these items. So give it a try if you would like to recreate this. And anyway, I hope you enjoyed this. Have a great afternoon.